Now let us start into our digital circuit component overview and try to understand some commonly used digital component which are built with the basic digital component, which is basic logic gates and this flip-flop and latches, uh, and be used in the computing system, especially in the processor. So one such component is called decoder. Okay? Decoder converts, by definition, n-bit code. Like at the input side we have n-bit, let's say, and output side there are m bits, and from n bits combination it will create m bit unique output binary code where we have a relation between n, m and 2 to the power n. So n has to be less than equals m, has to be less than equals 2 to the power n. So let's say I have like 3 bit at the input side, then my output has to be 3 or more, but cannot be more than 8. So that's what this relation is saying, n less than equals m less than equals 2 to the power n. And it has to create unique sequence of the at the m, at the output side, number of m. Okay, we often use the term n to m line decoder, which produces m bit code such that only one bit at the logic one at a time. So we have a definition of a line decoder, and this line decoder is the one we commonly used in computing system, in the processor. Okay, line decoder. So n to m line decoder, it produces m bit code such that only one bit is at logic 1, every other bit is at 0. So for one certain combination, one of the m bit will become 1 and everything else is 0. And usually in this case, line decoder, whenever we call line decoder without any other further constraint, like n bit line decoder, that we assume there your m equals 2 to the power n. Okay, usually. But strictly theoretically speaking, this is to produce 2 to the power n or fewer min term. We can have less than 2 to the power n number of output in that line decoder, and we still call it a line decoder, but that is a mere technicality ground. Okay, if at least let's assume in this class, if I use the term line decoder, n bit line decoder, I mean there is a n input and 2 to the power n output. Okay, unless I specifically says, hey, there is like n bit, like, okay, 4 bit and to, like, let's say 8 bit line decoder, 4 to 8 bit line decoder. In that case, we'll assume there's a 4 input and 8 output. But if I say it's a 4 bit line decoder, we'll always assume my output side is 16 bit, 2 to the power 4, which is 16 bit. Okay, so just a little note, please make it a note that what we call a line decoder. Okay, so it is to make, it is an decoder, it has n input and 2 to the power n output, and each output, like for each combination of the input, only one bit of the output side will become 1 and the rest of the bit will be 0. So 1/2 line decoder is a very simple circuit where it's convert from 1 to 2, 2 to the power 1 is 2, like, and we term it as a m0 m1. Okay, so it is not a surprise that this output terminal is basically represents your min term of the corresponding input bit sequence. So that's why we usually mark this output for line decoder as in a min term notation, like min term 0, min term 1. So if my A is 1 bit input, then 0 is a min term 0, right? And 1 is min term 1. So I have 2 min term for this 1 bit input, and if A comes to 0, it is min term 0, means m0 has to be 1 and M1 has to be 0. If A is 1, then minterm 1 will be 1, indicating, okay, minterm 1 has arrived and minterm 0 will remain 0. So to do that, if we look at this this table, it is practically using an inverter, right? Your M0 has an inversion relation with A, and M1 is a direct relation. We can just connect this line directly A to M1. We could have used a buffer, that would be better. It will just strengthen the signal and so on and so forth, but it's up to you. Like inverter and straight line is fine. Or we can use a buffer between this A and M1. Now, second, let's bring up 2 to 4 line decoder. 2 to 4 line decoder is like this. We have like 4 combinations, like 2 input A1, A0, and let's assume A1 is the MSB, A0 is the LSB. That's usually the case unless it is specified. Your higher index is a higher bit and lower index is a lower bit. So it is 0, 0, 0, 1, 1, 0, 1, 1. And your M0, M1, M2, and M3 are the 4 outputs, and outputs are like this. Like if it is 0, 0, it is minterm 0, right? That's why it is 1 and everything else is 0. If it is a 0, 1, it is minterm 1, so minterm 1 should become 1, and everything else is 0. Similarly, minterm 2, minterm 3. So in the whole truth table, you can see your 1 is kind of a diagonal in the table, and rest of the table is practically filled up with zeros. Okay, it's just one bit is 1 among 4 output bits for the line decoder. How it is achieved? We can use a 1 to 2 line decoder. Okay, 1 to 2 line decoder means it is a 1 input 2 output. 2 to 4 line decoder means it's 2 input 4 output, something like that. So this guy 1 to 2 line decoder gives you A0 bar and A0, and another 1 to 2 line decoder gives you A1 bar and A0. Then you need to combine it through the AND, right? Your M0 is A1 bar, A0 bar, so you AND them. Your M1 is A1 bar, A0, M2 is A1, A0 bar, M3 is A1, A0, so you're placing logically AND, connecting them through the AND, and making your decoder circuit. And it will become truth table like this. Now I want truth table with an enable. What is this enable means? Enable, if it is 0, whatever the value of A1 and A0, X, don't care, our output will become all zeros. It will be 0. It is not an active anymore. That's what it kind of digitally means, that it is not active. So enable is to activate this circuit. If it's 0, E is 0, then all my decoder output is 0. It is basically implemented very easily. Take a usual 2 by 4 line decoder, add another 4 AND gate, and one of the input of this last stage of the output is last stage of this logic, these 4 AND gates, one of the input is E. Okay, so if E make it 0, then output from all these last stage last stage AND side, output of them will be all zeros, right? It will set the M0, M1, M2 and M3 to zeros, and only if it is 1, the E is 1, then only it will start. You can imagine as sending out the output of the inner 2 by 4 line decoder into the output of this whole 2 by 4 line decoder with the enable, right? So it will start acting like a normal 2 to 4 line decoder. It will reflect what minterm came in and so on and so forth, only if E is 1. If E is 0, all the output is 0. So that's an enable.